So in this example, we want to look at the Pythagorean theorem. Now, the Pythagorean theorem is used whenever we want to find the missing side of a right triangle. So first, we need to start with our formula. So that's going to be, for our Pythagorean theorem, that's going to be a squared plus b squared is equal to c squared. And we know that c is always the longest side of our triangle. So if you ever do the Pythagorean theorem and your hypotenuse, c is not the longest side, then you know that you made a mistake somewhere. So we have here a squared plus b squared is equal to c squared. So now, right here, this acute angle theta, this is our point of reference. So if you remember, the 12 is the opposite side and the 5 is the adjacent side. So let's go back down to it, and all we have to do is plug everything in. So we're going to say 12 squared plus 5 squared is equal to c squared. That's the part that we don't know. 12 squared, once again, plus 5 squared is equal to c squared. So now we can just solve everything. We could say 144 plus 25 is equal to c squared. And we know that 144 plus 25, that's going to give us 169, which is equal to c squared. And we just take the square root of both sides to undo this, the c squared. So the square root of 169 is 13, and the square root of c squared is c. And that's how we solve this problem. And once again, as we said before, that is our longest side, the hypotenuse. So now, y'all, we move to this next problem. Now, if you notice, we switched our triangle around a little bit, but that doesn't matter. This is still our point of reference, this acute angle. So now the 4 is the opposite side, and we're actually missing our adjacent side, and we're given the hypotenuse. But once again, we still want to make sure we go back to our formula. A squared plus b squared is equal to c squared. Put our 2's in here. Once again, a squared plus b squared is equal to c squared. And now, when we go back through, our a squared, that's going to be 4 squared, plus b squared, which is the unknown, is equal to 7 squared. Because remember, in this problem, we're given the hypotenuse. In the last problem, we were looking for the hypotenuse. So we continue to solve this problem. Yeah, that's 16 squared plus b squared is equal to 49. Let's put our squares right here. I forgot that. Okay, this should be an equal sign. And now, when we go back to it, we're going to have, remember, we have to subtract 16 from both sides. So 49 minus 16 gives us 33. So we have b squared is equal to 33. That is not a perfect square. And we're not looking for decimals. So we just solve this as b is equal to the square root of 33. Okay. Now the square root of 33, as we know, is going to be a little less than 6. And as we said before, it's less than 7, so we know we're okay. So now I want to go a little bit further right here. Now we can find all of our missing sides. I'm sorry, now that we found our missing sides, we can find all of our trigonometric values. So we know that the sine was equal to the opposite over the hypotenuse, which is 12 over 13. We keep going. The cosine was equal to the adjacent over the hypotenuse, which is 5/13. And the tangent was equal to the opposite side over the adjacent side, which is going to be 12/5, 12 over 5. Now, we remember the reciprocal identity. So cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So all we do now, we just reciprocate this. So instead of 12/13, this is going to be 13 over 12 because this is what the hypotenuse over the opposite. Okay, the secant is going to be the reciprocal. And here the cotangent is also going to be the reciprocal of tangent. So as long as we remember those, it'll be pretty straightforward. And we could do the same thing on this side. We could easily find all 6 trigonometric values once we find our missing sides.